Okay, viewers, this is Dr. James Wonder speaking, and it's the late night on Wednesday, the 1st of October 2025, and I'm in my supported housing bedroom for the homeless in Coventry making this video. And earlier, I made a video regarding the safety aspect of ionizing fire alarms in particular. And I mentioned that there are safer alternatives to ionizing fire alarms and that are not radioactive. Also, those are photoelectric fire alarms and multi-sensor fire alarms, which are also available. But people need to be made aware that currently the standard cheap fire alarms on sale are actually mostly ionizing type of fire alarms, and that's what I mentioned in my previous videos. And they do pose a small risk, a very small amount, but still a risk. And I did mention my personal case, and I suspect maybe my hair loss and some other um, effects attributable to possibly uh, fire alarms in an enclosed area, in particular, not necessarily this particular location, but my last location, which was sealed with patio doors being sealed and no windows or even a vent to let air in. It was that bad. So I was breathing that same air constantly, and the only way of not breathing that air was leaving the room to get fresh air, and that was at my previous location on Wolfsgrave Road in Coventry, also a supported housing accommodation. So that's where the effects were first observed. But even this one here, this room has also got the same standard fire alarm. So it might be still going on up here, but maybe because I've got some control over the windows, I've got open windows here that do close and open. So it might be better in that way, but it's still not over completely. The risk is still there, even though they say it's minimal risk posed by these sort of fire alarms. The radioactive material used is obviously from a substance mostly called Americium, and that's the substance that is used in many modern firearms that are of ionization type. And it does emit alpha radiation, alpha particles in the chamber in particular, and that's the process it uses to detect smoke. For instance, when the smoke enters the ionization chamber through the alpha particles there that are being emitted, and the sensor obviously picks it up through the electronic circuitry. But I did mention also that other things that are kind of unsafe in the science and engineering side of things, uh, in an analogous way, have also been kind of modified for the better. And I'll give you examples, and I did mention it in my previous video. For instance, everyone's heard of the hydrogen airship, the tragic incident in New Jersey on the 6th of May 1937. That was a turning point, in fact, the end of the era of hydrogen airships. Not exactly fire alarms, but obviously hydrogen being very flammable. They learnt the lessons from that, and from then onwards, there were no usage or reliance on hydrogen airships in particular, and they used a safer alternative inert gases such as helium, for instance, to do the same job, which is obviously a lot less, lot safer, and a lot less hazardous in terms of flammability, etc. So that's something that's improved, obviously, from that history lesson, obviously. So knowing that hydrogen is flammable, of course, and not using that for airships to avoid those sort of disasters, and moving on with like helium, for instance, instead, or other gases that are safer. And also other examples like if you can recall, in the 1980s, chlorofluorocarbons were deemed to be responsible for the depletion of the ozone layer, causing a hole in the ozone layer, and that was obviously uh, observed through computer animation, and there were conferences around climate and everything, and governments around the world had protocols to ban chlorofluorocarbon products, and they were successful in that, and and they did achieve a reduction in the ozone layer depletion, and that was marked significantly by that by the improvement in the fact that they didn't rely so much on chlorofluorocarbons and they were banned. Aerosols, in particular, used a lot of chlorofluorocarbons, if you can recall, and also refrigerants that were collected, old refrigerants, and they were usually dumped in scrap yards, etc., and metal places where they were used for recycling, and they would release harmful chlorofluorocarbons, and obviously damage the ozone layer, and they were responsible for the depletion in the ozone layer, causing a hole there. But when the sales of that product of the chlorofluorocarbons products were banned and alternative substances were introduced, there was a remarkable reversal of the ozone layer depletion. So that's something that's also been successful. Something a known cause to cause damage or hazard in terms of, and obviously, what's the hazard of having the ozone layer? Obviously, if there's no ozone layer, you'd have you know a risk to mankind, humanity, and animals and life on Earth. Actually, penetrating harmful radiation from the Earth, ultraviolet harmful radiation could cause extra skin cancers and melanomas, etc. So that would be observed as well. So that's the reason why it's there is to protect, obviously, from people from having that or suffering from those sort of symptoms. But it's not still saying that it's safe. Even if you do have a ozone layer there, it doesn't mean you can go out and not wear your suntan creams and your protection. All it means is there's more risk. Because obviously you're more exposed to harmful rays from electromagnetic rays from the ultraviolet region, in particular the higher bands, and as a result, especially in those regions where there was that depletion observed, there'll be more of that harmful radiation penetrating through, causing more skin cancers and things, and even, like I said, melanomas. So that's the reason why it needed it to be there, and it needed to be protected, almost like an SSSI, a scientific interest, but not necessarily an animal conservation, but something that's natural, part of the earth, the ozone layer. So that needed to be protected, obviously, and they had treaties and protocols to ban the proliferation of the sale of chlorofluorocarbon products, and that was successful. And also, I made reference to analogous drugs on sale, and I gave a classic example in that film, The Fugitive, starring Harrison Ford and Amsterdam-born bad guy in that movie, Jerome Crabbe, who plays Dr. Nichols. And as you can recall in that film, they actually approve a drug that is known to cause liver damage, and those results were falsified, and to clear the drug and allow it to be sold as safe for consumption to the public, etc. So that was Valproic, or I think that's the name of the drug in that film, The Fugitive, and that it centered around that the corruption around that drug in particular, and the American Food and Drug Administration, the FDA, who cleared it, obviously, but they obviously falsified the reports of the liver samples, which would have proven that they do cause liver damage, that particular drug, and they wouldn't have then therefore approved the sale of that drug if it had known effects like such as damage to the liver cells, etc. So that's just an example, obviously, and that goes on all the time, obviously, and even products like fire alarms, if they're known to cause some sort of, even if it's a insignificant effect, any risk, is still a considerable risk, isn't it? Why take the risk when there are safer products out there? Something that doesn't cause radioactivity. Like I mentioned, multi-sensor firearms and also photoelectric fire alarms. I mean, they don't pose no risk from radioactive materials. So it's like playing, you know, with a fire or something. Why take the risk of having hydrogen airships? Would you do that again? Of course not. When hydrogen is known to cause, and it's likely to be flammable, and even a small spark or something would ignite it, like the Zeppelin disaster in New Jersey back in 1937 on the 6th of May. So that was a turning point. Again, maybe even with fire alarms like that, maybe there needs to be a turning point there. Why rely on those sort of products? That's what I'm saying here. And Obviously, the argument here is that those particular fire alarms have been approved. The safety inspectors have approved it on the basis of natural background radiation, and on that basis, it's deemed a lot safer in terms of emitting radiation levels than the natural background radiation in certain parts of the countries of UK, for instance. There are obviously high places of natural background radiation, natural rocks, etc., and places like Cornwall, etc., where the natural background radiation is quite significantly higher than the average. In those sort of places, compared to them, relative to those, it would be justified as being safe. But we don't want to be all assumed to be living there, do we? So why take the risk? Even a small risk is a bad risk. I wouldn't take that risk, and I wouldn't recommend selling products like that. It's like if a drug is known to cause something, why sell it? And that's what people at the end of the day, people who market those items or products have got a lot of money at stake there, and they need to sell it, don't they, their product. And certain products don't sell, like the C5 Sinclair that never made it successful because obviously the visibility wasn't so good, being such a low down car. And the DeLorean car made in Northern Ireland, that wasn't a success. So certain things don't succeed anyway. And that's my message here. And usually safety features should overtake and override. And that's what I'm getting across here. So first of all, awareness. Obviously, people ain't aware of the issues here, and that there are radioactive materials used in these fire alarms, in the ionization type of fire alarms. And I should mention even cartoon characters such as Homer Simpson in The Simpsons. I mean, he's lost his hair, and I'm presuming it's from the known effects of radioactivity in a nuclear power station. That's the Springfield nuclear power station, and I'm not working in a nuclear power station. Put it this way, and I've lost that much hair, and my siblings don't seem to have lost that much hair. What could be the explanation for that? It's a bit of a coincidence, too much of a coincidence to rule out that these fire alarms are not responsible. And obviously, I'm not in a hazardous occupation either, so my exposure is should be minimal, obviously, and I'm not in a radioactive high natural background area either. And even mobile phones, some of them are also emitters of electromagnetic radiation of the non-ionizing form, but still electromagnetic radiation, which can cause damage as well. And you have to look at the SAR value for these phones. And obviously, the people who make these phones need to be obviously competitive, making sure their phones are safe. The SAR value in particular, the specific absorption rate, and that should be as low as possible. Anyway, so whatever they set that on as a threshold, a minimal threshold, but you shouldn't always go for that. You should seek for minimal electromagnetic radiation. Obviously, in your pockets and places like that, it can be still emitting radiation of a non-ionizing form. So anyway, do remember these people who make these products, engineers and technologists, they have a lot of money at stake and patent rights, etc. as well. Just like that diesel guy who was found dead mysteriously during the English Channel before the start of World War Two. I mean World War I, and things like that do go on. So do remember a lot of money is at stake in selling these products. So it is a business end of the day.